So finishing off this video, I will be showing you how to complete these exercises. So first things first, compute the derivatives of the vector value functions. So right here, the definition is just d over dt of these single sections. So this would correspond with x of t, this would correspond with y of t, and this would correspond with z of t. So I would annotate my stuff again with f prime of t, which equals to 3t squared, and g prime of t, which is equals to 6t, and h prime of t, that would just be 1/6 times 3 squared, and that would just be equal to 2 squared over 2. So basically, after doing all this, you just combine it back together into the vector function. So r prime of t just equals to 3t squared and I plus 6t j, and finally t squared over 2k. Okay, next question is, for the following problems, find a tangent vector at the indicated value of t. So this is just our vector r of t. So we're supposed to find the tangent vector. We're supposed to find the derivative of this tangent of this vector function. So again, we would do f prime of t. That would just equal 1. And then g prime of t. To figure that the sine 2t, we'd use a chain rule. So using that, we would just get 2 cosine 2t. And in the h prime of t, we use the chain rule again, and that would just be negative 3 sine 3t. So at this moment, now we're supposed to find the indicated value of t. So we just plug in t into our function, into t. So r prime of pi over 3, that just goes, there's no t in 1, so that just stays as 1. So that one is 2 cosine 2t, which is basically 2 cosine of 2 times pi over 3, and that would just be 2 cosine 2 times negative 1/2. That would just equals negative 1. So that would go here. And for negative 3 sine of 3 of pi over 3, this one cancels out, so we get negative 3 times 0 equals 0, so we get it here. So we are not done yet, right? So we have found the tangent vector at t equals pi over 3 to be 1, negative 1, and 0. So we need to normalize this vector. So we find the magnitude. So magnitude of r prime of t just equals to square root of these components. So we have 1 squared plus negative 1 squared plus 0 squared, right? So that would just leave us off with square root of 2. So the final answer just would be 1 over square root of 2 just times the vector. So 1, -1, and 0.